Numerical on equilibrium of parallel space force system. Question is, find tension in each of the cable supporting the rectangular plate of weight 500 Newton. This plate is supported by 3 cables at A, B and C, and the weight of this plate is 500 Newton acting vertically downward through CG, the center of the plate. So we'll assume that TA, TB and TC are tension in cable at A, at B and at C. Then weight W 500 Newton acting vertically downward. We'll draw free body diagram. So here this free body diagram shows TA, TB, TC tension in the cables. Point A, its location from x-axis is available. So here point A is at distance 1.5 plus 1 from A. It is 2.5 given in the FBD. B and C are at distance 1 meter from this line x-axis. CG, total length is 1 plus 1.5 plus 1, it is 3.5, and CG is half of the length, that is 1.75 from this side. Total width is 1 meter, so C will be at distance 1 meter from this Z axis, whereas CG has distance 1 divided by 2, it is 0.5 from this Z axis. So here we are assuming that the system is in equilibrium, means these 3 tension, force and weight are in equilibrium. So we can apply condition of equilibrium. We'll apply condition of equilibrium. Summation moment of all forces about this x-axis is equal to 0. So movement about this x-axis. So movement in this direction taken positive, movement acting in this direction taken negative. So here we are taking movement due to TA force is negative. It is acting at distance 2.5 from x-axis, minus TA into 2.5. Movement due to TB force, it is again negative. Movement due to TC force is again negative. This TB and C are at distance 1 meter from x-axis. So minus TB into 1, minus TC into 1. 400 Newton, it is going to create clockwise movement about x-axis. This 500 at CG is at distance 1.75 from x-axis. So 500 into 1.75 equal to 0. We will simplify this equation to get 2.75 TA plus TB plus TC equal to 875, equation A. Now we will take moment of all forces about the Z axis equal to 0. We will assume that movement along this direction is clockwise, that is positive. Movement along this opposite direction as negative. TA and TB are lying along Z axis, so their movement will be equal to 0. We are going to take moment of TC about Z axis. It is going to create a negative movement about Z axis, so minus TC at distance 1 meter. This 500 Newton weight create clockwise movement at distance 0.5. So 500 force into distance 0.5, and this total equation is equal to 0. So finally we will get value of TC from this equation equal to 250 Newton. Now we will apply condition, that is summation Fy equal to 0. So when apply this condition of equilibrium, we'll add TA, TB, TC going in vertically upward direction, minus 500 going vertically downward direction equal to 0. We'll put value of TC calculated earlier as 250. So this equation gets simplified as TA plus TB equals to 250 Newton. This is given equation B. Already we have equation A, 2.5 TA plus TB. Now instead of TC we put value as 250 Newton equals to 875. So this equation gets simplified as 2.5 TA plus TB equal to 625. This is given equation C. Now equation B and equation C are the two simultaneous equations having unknown TA, TB. Simplifying equation B and C gives value of TA as 250 Newton and TB value is 0. Whereas TC value calculated earlier is 250 Newton.